Regulators.
Regulators! Mount up!
Well, good morning, good afternoon, or good evening, depending on what time it is you're watching this short little video. In this lesson here, I'm going to go over with you how to solve by graphing. But first, I want you to read this right here. The biggest lie I tell myself is, I don't need to write that down, I'll remember it. Oh man, if I had a nickel for every time a student told me, I don't need to write that down, I'll remember it, I'd be a multimillionaire right now. Guys, write things down. The written word can always be heard. All right, write it down. You go back and read it again. It's like you're hearing it for the first time. All right, now let's talk about solving by graphing. Okay, there's two types of systems we're going to deal with. The first one I'm going to tell you is an inconsistent system. It's a system that has no solution. Okay, you get a graph like this where we're going to do lines right now, systems with lines. Right? If you graph the two lines, they never intersect. Or in other words, if they're parallel. Right? If you have parallel lines, they never intersect. That's called an inconsistent system. Okay, now a consistent system is a system with at least one solution. Consistent systems can be either independent or dependent. Okay, if you graph two lines that intersect in exactly one point, then that's called an independent system. The graph of an independent system consists of two lines that intersect at exactly one point. Okay, if it's consistent but dependent, it has infinitely many solutions. The graph of a dependent system consists of two coincident lines, or the same line. So if you have two different equations and you graph those equations and they make the same line, it's a dependent system. There's infinite solutions, right? If they intersect at one point, it's an independent system, only one solution. If they're parallel, they never intersect, there's no solution. Okay, so let's just do a few examples and see what's going on here. Here's a system we want to solve, and we'll solve it by graphing. Okay, 2x plus 3y is 2, and 3x minus 2y is 16. We want to graph both of these lines. So we're going to put them in slope-intercept form. Let's put them in the form y equals mx plus b. Right? When they're in standard form like this, we can do that in two steps. This top equation here, I'll take the 2x to the other side. I'll get 3y equals negative 2x plus 2. That's step one. Then I'll divide everything by 3. And I'll get y equals negative 2/3 x plus 2/3. Okay, the second equation, I'll take the 3x over, and I'll get negative 2y equals negative 3x plus 16. And I'll divide everything by negative 2. And I'll get that y equals, two negatives make a positive, so I'll get 3/2 x minus 8. So here's both my lines in slope-intercept form. Guys, isn't it cool that in previous unit we learned how to put linear equations in slope-intercept form and graph them? Now we're just putting those two things together. So for this first one here, and you know what? Maybe I'll come back here. I'm going to circle this one in blue. So when I graph it, I'll graph it in blue. Okay. So let's see. Here's the blue. And this was minus 8. So this first graph here, the y-intercept is 2/3. I'd like it if it was a nice integer, but it's not. So I'm going to go about right there is where I'm thinking 2/3 is. Then the slope is negative 2/3. So I'm going to go down 1, 2, and go over 1, 2, 3. I'll do the same thing, down 1, 2, and over 1, 2, 3. 1, 2, 1, 2, 3. Okay, now going down 2 and to the right 3 would be the same as going up 1, 2, and to the left 1, 2, 3. So up 1, 2, to the left 1, 2, 3. Up 1, 2, left 1, 2, 3. Okay, there's my line. So I'm just going to draw a line through these points. Okay, now see how I missed some of these points? I want to be really accurate with this. And I'm actually thinking I threw myself off with this last one here. Let's check this last one again. All right, we said go up 1, 2, and over 1, 2, 3. I only went over 2. That's what threw me off there. Okay, you want to use some straight edge so you can make sure you draw these lines straight. So here's our first line. Now our second line's a little nicer. The y-intercept's -8. So 1, 2, 3, 4, 5, 6, 7, 8. And the only reason I say it's nicer is because the y-intercept's a nice integer. Okay. Now the slope tells me go up 3 and to the right 2. So up 1, 2, 3 over 2. Up 1, 2, 3 over 2. Up 1, 2, 3 over 2. All right, look at that. Just by doing the slope, I found my point of intersection there, but I'm going to go ahead and draw a line through all these points. And again, I want to make sure to do an accurate line. Okay. Now, where they intersect is the solution, so they intersect right there. 1, 2, 3, 4 for x, 1, 2, -2 for y. Okay, that's our solution. Because this is a consistent system and it's independent because it has one solution. So this is a consistent, independent system. Now I'm saying the solution is 4, -2. I want to check that. So what I'm going to do is go back to the original two equations. I'm going to put 4 in for x and -2 for y. Okay, so in the first one, I'd have 2 times x, which I'm saying is 4, plus 3 times y, which I'm saying is -2. Let's see what that equals. Well, that's going to be 8 minus 6. Sure enough, that's 2. If I do it in the other one, I get 3 times 4 minus 2 times -2. See, 3 times 4 is 12. -2 times -2 is 4. 12 plus 4 is 16. I feel good about my answers. So the solution to this system is the point 4, -2. Right? We're looking for the point where they intersect. We call it a consistent system because there was an answer, and it's independent because there's one answer. All right, let's do another one. All right, this one here, we've already got our first equation in slope-intercept form. The y-intercept is 0. The slope is 3/2. So I'll go up 1, 2, 3, and over 2. Up 1, 2, 3, over 2. Up 3, over 2. I could go down 3 to the left 2. Down 3 to the left 2. Down 1, 2, 3 to the left 2. Okay, I'll draw a line through those points. Look how I always do it. I make one careless little mistake. On this one right here, I only went up 2 and over 2. Should have gone up 3, over 2. Okay. So I like to plot a bunch of points so I can see them line up instead of just 2 in case I make a mistake. If I got multiple ones there, I'll catch it, hopefully. Now, this second equation here, I can put in slope-intercept form, again, in 2 easy steps. First step, I'll take the 3x over. I'll get -2y equals -3x plus 6. And I'll divide everything by -2. So I'll get y equals 3/2 x minus 3. Look, scale this line back a little bit so it doesn't block that. All right, so the y-intercept is -3. 1, 2, 3. The slope is 3/2, so I'll go up 1, 2, 3, and over 2. I'll go up 1, 2, 3, and over 2. Up 3, over 2. Up 3, over 2. I could go down 3 to the left 2. Down 3 to the left 2. You guys seeing what I'm seeing? As I should have noticed it right away here, that these were parallel lines. Look at the slopes. This line has a slope of 3/2, so does this one. All right, they have different y-intercepts, so they're parallel lines. That means they never intersect. There's no solution. And what do we call it when they don't intersect, when they're parallel? You're right. We call that an inconsistent system. All right, this is an inconsistent system because there's no solution. All right, parallel lines never intersect. And you guys, let's do this too. I am not going through on these lines and putting the arrows saying they go on forever. Let's just say unless I put a dot at the end of a line, that it keeps going forever. If I do something like that, I put a dot, we'll say it stops there. Okay. All right, here's another one. Let's give this one a shot. And you guys, once again, the first or the top equation's already in slope-intercept form. All right. We go y equals 2x plus 4. So the y-intercept is 1, 2, 3, 4. The slope is 2, so I can always put that 2 over 1 to make it a fraction. I go up 2 over 1, up 2 to the right 1, up 2 to the right 1. I could go down 2 and to the left 1, down 2 and to the left 1, down 2 and to the left 1. I could keep doing that to fill out the points. All right, I clearly see that line right there, so I'll draw a line through it. Draw a line through all those points. Okay, make sure I get a nice straight line that matches up on them. Again, I'm not going to draw the arrows. We'll just assume it keeps going on if we don't have an arrow. Now the second equation, I want to solve that for y. Well, I've already got the 2y here, so all I really have to do is divide everything by 2. Okay, when I do that, these 2's cancel, so I'll get y by itself. Then over here, I'll get 4 divided by 2 is 2x plus 4. Whoa, you guys look at this. Our two equations are the exact same line, right? They were just in different forms. So if I graph this other one, I'm going to get the exact same line. That means any point, any pair of x and y's that make this true also make that true. That means there's infinite solutions. Right? It is a consistent system. It's consistent because we can get an answer, but since there's infinite answers, we say it's dependent. Right? If there's only one answer, we say it's independent. Right? Go back to this first slide that I'm sure you wrote everything down. A consistent system is a system with at least one solution. They can be independent or dependent. If there's one solution, they're independent. Two infinite solutions, they're dependent. Okay? So, whoops. We had infinite solutions, so it's dependent. These two equations, the graphs were coincident. They coincided. They're the same graph. Okay? All right, let's try another one. And you guys, this might be a great time for you to pause the video, try to do this one on your own, then turn it back on and see if you did it right. All right, to do this one, I'm going to put both equations in slope-intercept form. So maybe I'll write them out up here. X plus 2y equals -4. We'll take the x the other side, and I'll get 2y equals -x minus 4. But I'm going to divide by 2. So we get y equals -1/2 x minus 2. And you guys, you're right. It is that easy. It's a simple two-step process. When it's in standard form, take the x term to the other side, then divide by the number in front of the y, and you have it in slope-intercept. So the y-intercept is -2. Then the slope is -1/2. So go down 1 and to the right 2. Down 1 and to the right 2. I'll just keep repeating that. See the pattern there. To the left, I'll go up 1 and to the left 2. Up 1 to the left 2. All right. So then I'll draw a line through all those points. Okay, there's the graph of x plus 2y is negative 4. Now the other one, when I graph this other one, let's see, we've got x minus 1/2 y equals 6. Okay, I'm going to do the same thing. I'm going to take the x to the other side. It becomes negative. So I get negative 1/2 y equals negative x plus 6. Now, I'm going to do the exact same thing. I'm going to divide everything by negative 1/2, just like I did on the other one. Take the x to the other side, and then divide by the number in front of the y. That way those cancel, and you get y by itself. Two negatives make a positive, and then when you divide by a fraction, you flip and multiply, so you get 2x. This is going to be negative. Positive divided by negative is a negative. Divide by 1/2, you flip and multiply by 2, so you get 12. 2x minus 12. Now, because my graph here only goes down to negative 10. So I could sort of estimate negative 11, negative 12 would be right there. Okay, and then the slope is 2, so I would go up 2 and over 1, right? Because that'd be 2 over 1. And then I'd go up 2 and over 1. Up 2, I'd say over, but I really mean to the right. Up 2 and to the right 1. Look at that. Just by plotting points from the slope, I've got the answer. That's the answer right there. And maybe I'll do a couple more points just to graph this. All right, if I draw a line through these points, I'm not going to do this one here because I just estimated it. But when I was on the graph, I got it pretty accurate right there. Okay. Because here's our answer right here. This is what we're looking for. We're looking for the point where they intersect. So that's 1, 2, 3, 4. 1, 2, 3, 4. That's the point 4, negative 4, right? They intersect, so this is a dependent system, or excuse me, they intersect, so it's a consistent, I'll write it down, it's a consistent system, and they intersect at just one point, so it's an independent system. Okay, now I'm going to box in my answer, but I'm also going to check it. I'm going to check it in both the original equations. So if I plug 4 in there for x and negative 4 for y, I'll get 4 minus 4, which is negative 4. That's what we want it to be. And the other one, if I put 4 in for x and negative 4 for y, I'll get 4, then a negative times a negative is a positive. Half of 4 is 2, so 4 plus 2, look at that, it equals 6. It checks out. Okay. Always, you guys, check your answers, when you, especially when you do by graphing, because if your graph's off a little bit, you might get a little bit of an error in your answer. You're looking for the point where they intersect. Once you get that point, plug it back in the original system to see if it's true. You guys, that's really all there is to it. Okay, solving by graph. Hey, we know how to graph lines. Now we're just adding an extra thing. We're looking for where they intersect. Okay, we should be able to say if the system is consistent or inconsistent. Remember, if they're parallel lines, they never intercept. They're inconsistent. If they intersect at one point, it's a consistent, independent system. Anytime they intersect, it's consistent. If it's at one point, it's independent. If the lines coincide, there's infinite solutions, and we call it dependent. Okay. Intersect at one point, it's a consistent system, and it's independent. Okay, because make sure you do the homework. Work your hardest, try your best, and always endeavor to persevere.